Dr. R. Sugurat Samuel is working as professor in physics in SRM University, Chennai. He is also training students for IIT JEE, AIEEE and BITSAT. He has more than 16 years of academic experience both in teaching and research. He has published a book titled The Complete Handbook of Bachelor of Electronic Science Practicals. It is prescribed book in the syllabus for BSc Electronic Science by University of Madras. He has attended and presented papers in several national and international conferences and conducted many training programs and workshops. He has experience in both regular classroom teaching and also online teaching. His research areas are ultrasonics, polymers, crystal growth, and photovoltaic systems.
Welcome to UGC lecture series on Applied Sciences Electronics. We have been listening to a series of lectures for the BSc Electronic Science degree program. We are discussing the subject Electricity and Basic Electronics, which is in the first semester of the program. This lecture is the 37th lecture in the series. Before we start today's lecture, let us see today's session outline. In this session, we are going to see the introduction for transistor, transistor design, transistor current equation, biasing of transistor and working of transistor. The topic transistor is found in the 4th unit of the subject. We are going to see the electronic component transistor. In the previous lectures, we have discussed one electronic component, that was the diode. We have used the diode for the rectification, and then the diode was used for regulation of voltage and different applications like clipping and clamping we have seen as the applications of diode. And in this series of lectures, we are going to see yet another component, namely the transistor. What is a transistor and how it revolutionized the field of electronics? Let us see the background under which the component electronics was invented. The transistor was invented in the year 1947 by J. Bardeen and W. H. Brattain of Bell Telephone Laboratories in USA. That transistor was a point contact transistor. The first junction transistor, consisting of two back-to-back PN junctions, was invented by William Shockley in 1951. A transistor also contains the P and N regions, but three such regions are formed. Either the P or the N region is sandwiched between the two other regions. So, we have three regions in a transistor. Because of that, two PN junctions are formed. What are the three regions called? We have two types of transistors because of the sandwiched part has two different options of either to be of P or of N type. So, we have two types of transistors. And what are the three regions called? Let us see the arrangement of the P and N regions in a transistor. A junction transistor is a solid state device. It consists of a silicon or a germanium crystal containing two PN junctions. The two PN junctions are formed between the three layers. These are called base, emitter and collector. So, as I said, the three regions are now given the name. They are specifically called with the names base, emitter and collector. The base is sandwiched between the collector and emitter. So, from one end, if you look at the transistor, it has a emitter, base and collector regions, or from the other side, other view will give us the collector, base, emitter sequence. But whatever it is, the base is formed or it is found between the collector and emitter. Now, how the two junctions are formed? Because of the three regions, there are two connections, two joints. So, those two joints will have the p-n junctions formed. So, two such junctions are possible in a transistor. Because of this, a transistor is sometimes referred as BJT, bijunction diode, bipolar junction diode. Like that also we can call the transistor. There are some special types of transistors. They are called field emission transistors. They are called FET, junction field emission transistor. So, JFET, metal oxide junction field emission transistor. So, that is called MOSFET. Like that we have lots of such varieties of transistors. In this lecture, we are going to see the very basic transistor, which is a BJT or bipolar junction transistor. Let us see how the transistor looks when with the three regions, namely base, emitter and collector. All the three segments of a transistor differ in thickness and doping levels. Emitter, this is the segment on one side of the transistor. It is of moderate size and heavily doped. It supplies a large number of majority carriers for current flow through the transistor. The next one is base. This is the central segment. It is very thin, of few microns thickness and lightly doped. Collector, this segment collects a majority portion of the majority carriers supplied by the emitter. This collector side is moderately doped and large in size. This is to enable the collector to dissipate heat. The three regions differ in the size and the level of doping. So, to bring it as a nutshell, the emitter is heavily doped as far as doping levels are concerned. Then the collector is moderately doped and base is very lightly doped. What is the level of doping? This concept we have already learnt when we learnt about the P and N type semiconductors. The doping is done in parts per million. So, in the case of emitter, it is a heavy doping, and next comes the collector, which is moderately doped, and base is lightly doped. The emitter and collector will be of the same type and the base will be of the other type of semiconductor. And in terms of thickness, when we look at the three regions, the base is very thin. It is of few microns in thickness. Then comes the emitter, which is moderate in size, and collector is the largest region, because the majority carriers are collected in the collector region. So, because of the acceleration or the movement of charges happening in the collector region, lot of heat will be evolved in the transistor, especially in the collector. So, that heat is to be sent or it is to be radiated out. So, for that the collector region is of larger in size. Now, we have got an idea about the way in which the three regions are doped and also their sizes. Now, what are the ways in which these can be arranged? Let us have a look at the concept. An ohmic contact is made to each of these layers. The junction between the emitter and base is called the emitter base junction, and the junction between the collector and base is called the collector base junction. Each region could be connected to an external circuit. So, for that we need leads, the connecting wires. To enable the connecting wires to be fixed, or we call that as the probes or legs in the transistor, we have metal contacts. These legs or these connecting leads are connected to the metal sections of the semiconductor material. This is how a PN junction transistor, it has emitter, base and collector regions. All the three can be externally connected using the metal leads. So, E, B, C refers here as emitter, base and collector, and this is also the same thing, and carefully the thicknesses are chosen. Emitter and collector, when we compare, collector is larger in size and the base is in between, it is very thin. And now we see two transistors. This is having the order NPN and this is having the order PNP. So, this itself implies there are two types of transistors possible, namely the NPN transistor and PNP transistor. We are going to see what are these NPN and PNP transistors and how do we represent them in a electrical circuit. The very symbol used for representing a transistor also we are going to see for these two types of transistors. Now, we have got a schematic diagram of the transistor, how it actually looks when it is seen as a component. Let us have a look at the diagram. This is how the transistors look like. You have cap type transistors, flat bedded transistor, and these types of designs enable the transistors to be fixed in electrical circuits. But in all the transistors we have this C, B, E leads. The order is also different. Sometimes the base is in the middle, but when we look at this transistor TO220, the base is at the extreme, emitter is at the extreme, the collector is at the center. And when we take this model, here also the base is at the extreme, emitter is at the other extreme and collector is in the middle. Whatever it be, inside the transistor the order is emitter, base, collector. The base is always found in between the emitter and collector. Only the connecting leads are arranged externally in various orders for various purposes, but internally the base is found in the middle, or it is found in between the emitter and collector. Let us see how the circuit symbol is used for the PNP transistor and NPN transistor. We will see that after a short break. Welcome back. Now, a question arises in our minds. In the case of a diode, we have a P and N region and a junction formed in between. Is it possible to combine two diodes in a series manner so that a transistor is obtained? Because in the case of two diodes connected in series, namely the P and P region connected together, the extremes will have N regions. So, in that case, can a diode which is connected in series with the same regions joined together act as a transistor? Is it possible? Just now we have seen these regions differ in sizes and also in the levels of doping. When we take a diode, the two regions are equally doped in the levels. N region and P region, when we consider, the level of doping is uniform, it is the same. And second thing is the size, the thickness is also the same. The size of the N region and the size of P region more or less be the same in the case of a diode. So, when we join two diodes so that a transistor kind of connection could be obtained, will not work out as a typical transistor, because the regions have different thicknesses and the different levels of doping. So, a transistor has to be specifically designed. Let us see that in the slide. The emitter region is heavily doped, since it has to supply majority carriers. The base is lightly doped. The collector region is lightly doped, since it has to accept majority charge carriers. It is physically large in size. Hence, emitter and collector cannot be interchanged, and also we cannot use two diodes to form a transistor. Similarly, the emitter and collector regions also cannot be interchanged in the case of a transistor. As I said, there are two types of transistors, namely NPN and PNP. How the junctions are formed in the two types of transistors? Let us see how the transistors are represented in the circuit. A transistor has three doped regions forming two PN junctions between them. There are two types of transistors, NPN transistor and PNP transistor. This is the circuit symbol of the transistors. On the top, the circuit symbol is the NPN transistor. It has a small segment, a straight line, from which two slanting lines are drawn, one representing the collector, the other one representing the emitter. How do we distinguish between the collector and emitter? The emitter will have an arrow mark and the base is connected to the collector and emitter internally. The circle here is optional, but whatever it is, the emitter will have an arrow mark by which it is identified, and the direction of the arrow has a significance. In the case of NPN transistor, the arrow mark is outwards, and in the case of PNP transistor, the arrow mark is inwards. What is the meaning of this arrow? Does it convey anything? The direction of arrow on the emitter terminal represents the direction of the conventional current in the transistor. We know what is the conventional current. The conventional current is opposite to the direction of flow of electron. So, this might be the direction of the positive charges, or in better terms, it is opposite to the flow of electron. So, this arrow mark has a significance. It tells the conventional direction of current in the transistor. How the PNP junction transistors are formed, and what are the two junctions formed in transistors? Let us have a look at it. NPN and PNP transistors. NPN transistor, two segments of N-type semiconductor, namely emitter and collector, are separated by a segment of P-type semiconductor, which is the base. And in the case of PNP transistor, it is just the reverse. Here, two segments of the P-type semiconductor, termed as emitter and collector, are separated by a segment of N-type semiconductor, which is termed as base. In normal sense, how do we recognize a transistor as a NPN or PNP transistor? Because once the transistor is designed and covered with an external cap and only the leads are available for connection, how do we know that particular transistor is an NPN or PNP transistor? We have a mechanism of coding them. So, those are the ones help us to identify whether the transistor is a PNP or NPN transistor. It comes out with the specification of the transistor itself. Let us see how the specifications are done. And to give an example, few PNP and NPN transistors are represented. This is one series, AC125, AC126, it is called AC series, 128, 132, like that. All these transistors are PNP transistors, and we should not think that if it starts with AC, then it is a PNP transistor. It is not so. Even in NPN transistor also there is a AC series, the AC 127, 176, 187, all these are the NPN transistors. And here we have BC series, BC 107 is a NPN transistor. At the same time, BC 157 is a PNP transistor. And for these set of transistors, this will be the bottom part of the transistor. It will have cap, which is just the two-dimensional diagram only we are seeing, and one terminal, it will be like a triangle. The extreme vertex of the triangle is the base, and these two are the emitter and collector. To distinguish between the emitter and collector, there is a small projection, a metal projection is there near the emitter, by which we will be able to identify that terminal is a emitter terminal. So, this is sometimes called as the can type transistor. It will have a metal cap above it. This is representing only the bottom part of the transistor. And here we have another set, it is NPN transistor, and this will have a flat bedded shape. This is again the bottom, the typical bottom of the transistor is only shown here, and once a triangle is formed, the one vertex which is there in the middle is the base, the other two are emitter and collector, for which we have to hold the transistor in the particular position as it is shown in the diagram. We have to hold the transistor in the particular position to identify the base, emitter and collector terminals. By the number and by the way in which the leads are fixed to the three regions of a transistor, we can identify which lead is the base and which lead is the emitter and which lead is the collector. And with the numbers, we will identify whether the transistor is a NPN or PNP transistor. These two types of transistors have their own purposes. In electronic circuits, we use them for different purposes. There are electrical circuits in which the speed is required. We need the fast operations, for which one type of transistor would be ideal. In some sorts of electrical circuits, we may require quite a bit of accuracy. For accurate values, for accurate functioning of the circuit, we may have to use a particular type of transistor. So, these transistors are plenty in number, and accordingly we will have to choose them for a particular purpose. We have discussed the concepts of transistor at an introductory level. The transistors are used for different purposes in electrical circuits. The two purposes are either it would be used as a switch or it would be used as an amplifier. These are the two main purposes of a transistor. Let us see how the transistors are used. The biasing of a transistor is done differently for different uses. The transistor can be used in two distinct ways. One is a switch, the other one is an amplifier. In general, for a transistor to work, the biasing to be done is given as below. Biasing of transistor. The emitter base junction is forward biased, so that majority charge carriers are repelled from the emitter and the junction offers very low resistance to current. The collector base junction is reverse biased, so that it attracts majority charge carriers and it offers a high resistance to the current. These are the two ways by which we bias a transistor. Emitter base junction is forward biased and the collector base junction is reverse biased. Only then a transistor will function properly. If the biasing is not done with the rules that just now we have seen, the transistor will not work. So, biasing is a very important criterion as far as the proper working of a transistor is concerned. Let us see how the biasing is done for a particular transistor. As it is mentioned, the emitter base junction is forward biased here and the collector base junction is reverse biased. The emitter is a p-type material, so it is connected to the positive, and here the collector is p-type material and it is reverse biased. So, this diagram clearly says how the biasing is done as far as a transistor is concerned. And to have a thumb rule or a shortcut way to remember, the input is forward biased and the output is reverse biased. Like that we can keep in mind. Have a look at the diagram. This is the input side of a transistor and this is the output side of a transistor. We give input and take output. So, input side is forward biased and the output side is reverse biased. We have seen how the biasing is done, and lot more are to be learnt regarding the biasing of a transistor. Let us see the elaborate concept about the biasing and the way in which the connections are possible with the three terminals of a transistor. Let us see in the upcoming sessions. Before we wind up today's lecture, let us see today's session summary. In this session, we have seen the introduction for transistor, transistor design, transistor equation, biasing of transistor and working of transistor. Let us test our understanding by answering these questions. Give the doping and thickness specifications of the three regions of a transistor. Explain the general biasing condition for proper working of a transistor. So, with this, I would like to conclude today's lecture, and let us see the other concepts related to transistor in the subsequent lectures. Thank you.